Question 1, linear inequality systems graphically, okay? So we need to try to graph this system, all right, for both these two equations, okay? So when you're graphing a system, you need to make sure that your system is in the form y equal mx plus b, all right? Where you know that m is your slope, okay, and b is that y-intercept, okay? And y is your total, all right? So when we're graphing this, guys, the first point you're always going to graph is that y-intercept. So in this case, the y-intercept is -3 for this equation. So we graph this, all right, first, okay? So we're going to graph -3 on the y-axis, okay? Now I'm going to apply this slope, okay? So my slope is -1/2. So that means you're going to go down once to the right 2 times, okay? So I'm going to go down once and then to the right 1, 2, okay? So now you're going to ask yourself, what type of line am I going to have, okay? Because this is a greater than sign, not a greater than or equal to, there's no line underneath, it's going to be a dashed line, all right? When there is a line underneath, it's going to be a solid line, okay? So again, no line, dash, solid line, all right, when there is a line underneath, okay? So again, because there's no line underneath, all right, this is going to be a dashed line, okay? So a dashed line, all right? Now you're going to shade, okay? But to figure out where you're going to shade, you need to look at this operator again, okay? Because it's a greater than sign, you start to ask yourself, if it's saying y is greater, all right, are you going to be above or below, all right? If you're greater, that means you're going to lightly shade above, okay? So you're going to shade above, all right? However, that's not our solution. So we need to graph our next line, okay? So the first point we're going to graph, all right, is my y-intercept. And my y-intercept is 6. So that's what I'm going to graph first, okay? So I'm going to graph 6, +6 on the y-axis. That would be right here, okay? So now I'm going to apply my slope. I don't see a number in front of the x, but I know that technically in front of the x is a 1/1. What does a 1/1 mean? That means that we're going to go up 1 because the 1 is positive and then to the right once, okay? So we're going to go up once and then to the right once. Now you're going to ask yourself, what type of line am I going to have, okay? Because this is a greater than or equal to, there is a line underneath. It's going to be a solid line. So again, solid line has a line underneath. If it did not have a line underneath, then it would be a dashed line. But because there is a line underneath, it's going to be a solid line, okay? So I'm going to draw my line and I'm going to make it solid, okay? Now I'm going to shade, all right? So when I'm shading, I need to look at the operator again. It's saying y is greater, all right? If I'm greater than my line, am I going to be above it or below it? I'm going to be above it, okay? So again, I'm going to shade above, okay? So now you're going to identify where your solution is, okay? So we have this area over here, okay? But that's not the solution because you don't have a mixture of colors. Here you only have blue, okay? Here we have no shading, so your solution cannot be there. Here we only have red. Here we have a mixture of both colors. So this is where your solution is, okay? So you can pick any set of coordinates to be a solution, all right? So for example, there's a coordinate right here. That could be a solution, -5, +4. So again, so you can see it's in that area. So because it's in that shaded area, it's a solution. So -5, +4 can be a solution. This is a solution. This is a solution. Any of these points can all each be a solution. So you can use also, if you did not want to use that coordinate, you could also use -7, 5. All right, because it's in that shaded area, all right? You could also use -1, 10, because that's all the way right up here, all right? So -1, 10 also works. Any of those could be a solution, but only identify one, all right? So again, just like that.